All right, hello and welcome back. Just as promised, we're going to talk more about angles today and some different relationships that are created with angles. Okay, so that's what our essential question is today. What angle relationships are created when two lines intersect? And also we got to figure out how to set up and solve an equation that involves a linear pair as well as congruent, supplementary, and vertical pairs. So let's go ahead and get straight into it. Okay, so here's this pair of scissors. When two lines intersect, kind of like a pair of scissors, the blades, you can make, like the blades here, you can make different angles from the way that the scissors intersect. Right, so what we're going to do is we're going to find relationships between each one of these angles. And we've kind of already discussed this in the first angle lesson. But where this correlates in your notebook, okay, we're going to be talking about complementary, supplementary, linear pairs, and vertical angles. So we have these different links that you can use. Most of these definitions are already filled in, so I'm just going to do the definitions over here today. But since we were talking about scissors, we'll start here with linear pairs and vertical angles. So last time we discussed that vertical angles are two angles that are across from each other when two lines intersect, and vertical angles are congruent. So in our box here, in this example, right, again, we discussed this in the previous video. We have two pairs of vertical angles, right? So angle 1 and angle 3 is one example. And then for our other example, we have angle 2 and angle 4. Okay, I want you to notice something that I did here. We haven't talked about this yet, but these arc marks, okay, that's what these are called. These are called arc marks. Okay, for 1 and 3, okay, 1 and 3 only have one arc mark, and arc marks are our way of showing congruency in angles. Okay, so we're going to make sure that we put this in our notebook. Arc marks show congruency, or here we'll say this, show that two angles are congruent. Okay. So instead of using the hash marks are only for segments. Okay, angles use the arc marks. So arc marks show that two angles are congruent. Okay. So in our example here, okay, we can say that angle 1 is congruent to angle 2. Now, if you're typing these, you can just use this symbol. That's perfectly fine. Angle 1 and angle 3 is one example. And then we also have angle 2 and angle 4 that are congruent. Okay, so that's one set of, or one definition that we took care of. Okay, the linear pairs, okay, these are a little bit different. Okay, but linear pairs are basically two angles that share a common side and they share a common vertex and they are supplementary. Okay, so linear pairs share a common side and vertex. They're supplementary. So let's come back up here real quick and talk about what complementary and supplementary mean. Okay, these two topics are one of the things that most people get very confused with. Complementary Okay, these are angles, and it doesn't matter if they're adjacent or non-adjacent. Okay, so these can be any two angles in which the sum of the angle measures is equal to 90 degrees. Okay, supplementary angles, again, are any two angles, adjacent or non-adjacent, in which the sum is 180 degrees. Okay, so complementary, these make the right angle 90 degrees, and supplementary, when you add up the two angles, they make 180 degrees, or a straight line. Okay, so supplementary, straight line, complementary, 90 degrees. Okay, so we'll come back to this in just a second. Okay, so linear pairs are supplementary, and they're a special kind of supplementary pair because the linear pair are right next to each other. Okay, so linear pairs are next door neighbors. That means that the two angles are going to be adjacent. Okay, so linear pairs are next door neighbors. Linear pairs are next door neighbors. Okay, so if I'm looking at next door neighbors, okay, I have quite a few next door neighbors here, right? So when I'm looking for linear pairs, I'm just looking for two angles that when I add them together, make a straight line. So the first one that I did here, I have angle 1 and angle 4. Okay, I could also take, on the opposite side, angle 2 and angle 3. Okay, so that takes care of this line right here that I highlighted in green. Okay, if we did the red line, okay, the red line also has two sets of angles that make up this line, okay? And those two are going to be angle 4 and angle 3. And then on the opposite side, we have angle 1 and angle 2. Okay, so notice what I did there with the lines. Okay, you pick a line. If you're looking for linear pairs, you pick a line, a straight line, and then you figure out which two angles, if I add them together, make up the straight line. Okay, so for linear pair examples, we're actually going to have 4. Okay, so we got angle 1, angle 2. We have angle 1, angle 4. We have angle 2, angle 3. And we also have angle 3, angle 4. This is 4 different sets of linear pairs here. All right, so before we get into the math, we're going to come back over here to some easier examples. These right here are more so just classification, or not classification, but naming. Okay, so if it says which angle is 119 degrees, that wants you to name the actual angle itself. Okay, so remember with naming angles, okay, there's 3 different ways to do it, and those 3 ways are right here. So 3 ways to name an angle. We do 3 points that make up an angle. So down here, I've got a total of 4 points, so I can definitely use 3. The second way is to use a number without the degree measure, okay, and that's going to be in between the 2 sides. So this 119 degrees and the 61 degrees would not qualify for the second one because they both have the degree measure attached to it. Okay, the third way that you can name an angle is with 1 point, but that is only if the angle is not adjacent to another angle. Okay, so it can't share a common vertex with anything else. It just has to be by itself. Okay, so this asks which angle is 119 degrees. So here's 119 degrees, okay? And the first thing that I'm gonna do is I'm gonna identify the two sides that make up this angle, right? So those two are right here. Now the points have to be on the sides that make up the angle, and where the two sides meet, okay, remember that's our vertex, that point's always gonna be in the middle. So there's two ways to name this one. We can either say angle A, we can start at A, go to C, and then D. Or we can go backwards and we can start at D, go to C, and then A. All right, so two different ways to go. You can either go like this, left to right, or right to left, it doesn't matter. Okay, now the second question over here says, what angle is 61 degrees? So if I want to figure out that angle, okay, 61 degrees is right here. Okay, I did it in green. Okay, so the green makes up the 61 degrees. Here's the vertex again, because this is where the two sides of the angle meet. Okay, now D is going to be used again, right? C is also going to be used because these two angles share the same vertex. But this time I'm going to come over here to B, because B is the last point or the last direction that I need to go to make up this angle. So I have DCB, or I can go backwards and I can say B, C, and D. Now this last box says, what is the relationship between these two angles? Okay, so I'll let you fill that in. That's on this slide here that we just talked about. Okay, and then you need to also explain how you know what the relationship is. So let's clear all this and come back over here. Directions for this, you can visit this website to explore complementary angles. It's just another website that it's GeoGebra. So GeoGebra is a cool tool that you can use to play around with things. But there's a little activity in here that helps you describe complementary angles and learn a little bit more about them. Okay, so it says in the applet below, the pink angle and blue angle are said to be complementary, and they want you to interact with it to basically show that it is. Right, so I can come here and I do the pink. Right, so there's just different tools that you can use to slide it. There's the blue. So when you add these two together, they end up making the 90 degrees. So that's what it's showing here. Now, one thing that you may see is what this says right here, a complement. So we'll discuss that in just a second because we have some examples here that we're going to talk about. So let's see, I think we already filled this in our notebook. Oh, no, we haven't talked about that yet. So we have talked about the linear pair and the vertical angles. So right here, using algebra says what type of angles are represented. So we're talking about the two that have numbers attached with them. So we know that this is a vertical pair. Now type of angles, that goes back to the classification. Right, so the first thing that we need to do is we need to classify these two. So since this angle right here is 114 degrees, that's going to be an obtuse angle, and the relationship between the two angles is the vertical pair. And the way that we can represent this relationship between the 114 and the 7x plus 23 is we can actually set up a formula, right? Because we know that they're equal to each other. So we can set up a formula and say that 114 is equal to 7x plus 23. So that's how I would set this problem up to figure out what the value of x is, right? So we want to figure out the value of x to verify that both of these are 114 degrees. That's the whole purpose of this. So when I solve for x, okay, this is all just algebraic stuff. So over here we got 114 equals 7x plus 23. Okay, I want to get the x's by themselves. So I'm going to subtract 23 from both sides. Okay, just doing the opposite operation here. And then what that ends up giving me is 7x is equal to, and then that number right there, see 114 minus 23, that is going to be 91. And then I come and I divide by 7 on both sides. So let me grab this guy. So I divide by 7. And what I end up with is that x, oops, that's not how I want it to. X is equal to 13. All right, so the value of x is 13. And now that we know the value of x, we want to take the value for it and we want to plug it back in here. And again, this is all just to verify that this angle is also 114 degrees. So what we would do is we would do 7 times 13 plus 23. 7 times 13 is equal to this 91. 91 plus 23, and sure enough, that gives us 114 degrees. Okay, so we can do this with any pair, right? It doesn't necessarily have to be a vertical pair. It can be any pair that we know about, right? So up here on this one, okay, the 44 and the 6x plus 10, okay, these are next door neighbors because they both share this side and they both share this vertex, okay? So when I add the 44 and the 6x plus 10, I get a straight line, which is right here in green. Okay, so we know that straight lines always equal to 180 degrees. So we have, in this case, we have, for the relationship piece, we have the linear pair. And since it's a linear pair, we also know that the two angles are supplementary. All right, if you have a linear pair, they're always going to be supplementary. Okay, the types of angles though, what types of angles are represented? Okay, we know for a fact that we have at least an acute angle, right, because of the 44. Okay, and then the 6x plus 10 looks like it's obtuse, but we need to verify it before we actually can call it obtuse. So we have to figure out what the measure of this is first. Okay, so the way that I would represent this problem using algebra is I'm going to take these two angles. I'm going to take the 44 and I'm going to add it with the 6x plus 10. And I know that they're supplementary, so I set it equal to 180 degrees. Okay, now from here, it's just combining stuff and solving for x. I'm just going to rewrite this 44 plus 6x plus 10 equals 180. 44 and 10 makes 54. Okay, so 6x plus 54 equals 180. Subtract 54 on both sides. And I get 6x is equal to 126 divided by 6. I get that x equals 21. Okay, so there's my 21. You can show your work down here in this box. Again, it's one of those things where you need to create a text box to do it. Okay, so we need to figure out, again, if this 6x plus 10 is obtuse. So I take the 21 and I'm going to plug it back in for this x. So we have 6 times 21 plus 10. 6 times 21 is 126. Plus 10, that gives me 136 degrees. And we know that obtuse angles are they're greater than 90 and less than 180. So we did verify that this one is obtuse. The angle is 136 degrees. Okay, so that's how you would do any linear pair in any supplementary, or any pair of angles that are supplementary. Okay, so what I'm going to do real quick is I'm going to just write some formulas down that may help you, and we'll discuss them in just a second. All right, so I've written down some helpful formulas for you here. We got vertical pairs. We're always going to set these equal to each other. So the two angles, you would just say angle 1 is equal to angle 2. And depending on what they want you to do, you would possibly solve for x, and then take x and then plug it back into, well, that's really not true with vertical pairs. Vertical pairs, you're typically just solving for x, unless they give you two expressions that have variables in it. Linear pairs, you're always going to add together and then set them equal to 180 degrees. So you would just say angle 1 plus angle 2 is equal to 180. And supplementary angles are the exact same as the linear pair. Okay, and the complementary angles, we're just taking two angles, adding them together, but this time we're going to set them equal to 90 degrees. Okay, so I would make sure that, you have all of this typed into your notebook, so that way you can reference it later. And that pretty much covers all of the information that we're going to talk about with respect to angles right now. Okay, so the big things that you should know how to do right now, number one, you should know how to define an angle. You should know how to name an angle. You should know what adjacent and non-adjacent mean. You should know the parts that make up angles. Okay, and then more specifically, you should know what complementary and supplementary mean, as well as how to set up problems and solve for missing angles like this. Okay, and you should also know what linear pair is and what vertical angles are, how to set these up and solve for variables. And we did some of these problems together. But again, we have some different activities that you can access. So if you have any other questions, here's some more formulas for you in this PowerPoint. I'll go ahead and make sure that we put that in Google Classroom for you. And you'll also have access to this graphic organizer. This is how it's going to look if you open it up for Google Classroom. If you save it and open it up as a PDF, it does this with the nice bubbles, right? So it's just the same thing that we just talked about, except it's just as a graphic organizer instead. So all these will be posted into Google Classroom. If you have questions, feel free to email me or leave it in the Google Classroom. And that concludes the end of this basics unit. In the next unit, we will talk about conditional statements, counterexamples, and different kinds of proofs.